There was no space, no time, no stars, no galaxies, no light. Then, in a moment beyond imagination, the universe began. Nearly 13.8 billion years ago, everything that would ever exist, every atom, every galaxy, every living thing, emerged from an incomprehensibly hot and dense state. The first 60 seconds after the Big Bang were the most important minute in cosmic history. In that first minute, the laws of physics took shape, matter began to form, and the fate of the universe was sealed. In the first 10 to the power of minus 43 seconds, a fraction of a fraction of a fraction of a second, the universe entered what physicists call the Planck Epoch. At this scale, temperature exceeded 10 to the power of 32 Kelvin. Gravity, electromagnetism, and the nuclear forces may have been unified into a single force. Space-time itself fluctuated violently in a quantum haze, sometimes described as quantum foam. Our current laws of physics break down here. To fully understand this era, we would need a working theory of quantum gravity, something science has yet to achieve. Then, in less than a trillionth of a second, the universe expanded exponentially. This phase is known as cosmic inflation. In an instant, space stretched faster than the speed of light, not violating relativity because it was space itself expanding. Tiny quantum fluctuations were stretched to cosmic scales. Those microscopic irregularities would eventually grow into galaxies and clusters. Inflation smoothed the universe, explaining why it appears so uniform across vast distances. Without inflation, the cosmos would look dramatically different. As expansion continued, temperatures began to fall, energy condensed into particles, quarks and gluons filled the universe in a dense, hot plasma. Electrons, neutrinos, and their antiparticles emerged. Matter and antimatter formed in nearly equal quantities. When they collided, they annihilated into bursts of radiation. Yet, for reasons still under investigation, a slight imbalance favored matter. For roughly every billion particle-antiparticle pairs, one extra particle of matter survived. That tiny asymmetry would allow stars, planets, and life to exist. Within the first microseconds, quarks combined to form hadrons, including protons and neutrons. The strong nuclear force began binding quarks together. The universe was still billions of degrees hot. But now, for the first time, recognizable building blocks of atomic nuclei existed. Structure had begun to emerge from chaos. Within seconds to minutes, the universe cooled enough for protons and neutrons to collide and fuse. This process is known as Big Bang Nucleosynthesis. Hydrogen nuclei formed first. Some fused into helium. Tiny amounts of lithium were created. The ratios were precise. Approximately 75% hydrogen and 25% helium by mass. Those proportions remain measurable in the cosmos today. They serve as powerful confirmation of the Big Bang model. In less than a minute, the chemical foundation of the universe was established. Though nuclei existed, atoms could not yet form. The universe remained too hot. Electrons moved freely in a glowing plasma. Light could not travel far. It scattered continuously. The cosmos was opaque. It would take nearly 380,000 years before electrons and nuclei combined to form neutral atoms. When that happened, light finally traveled freely, leaving behind the cosmic microwave background radiation we detect today. We cannot observe the first seconds directly, but their fingerprints remain. The cosmic microwave background reveals temperature fluctuations that trace back to quantum ripples during inflation. The observed abundance of hydrogen and helium matches nucleosynthesis predictions with remarkable precision. Satellites such as the Planck Space Observatory have mapped this radiation in extraordinary detail. The data tells a consistent story. The universe began hot, dense, and rapidly expanding. Every galaxy, every star, every planet, every living organism, all trace their origins back to the physical laws established in that first minute. The balance between matter and antimatter, the strength of nuclear forces, the rate of cosmic expansion. If any had differed slightly, the universe might have been lifeless, or never formed complex structures at all. In just 60 seconds, the universe transitioned from incomprehensible energy to structured matter. It laid down the blueprint for everything that would ever exist. The first minute after the Big Bang was not merely a beginning. It was a transformation from nothing to everything. And we are its living consequence. Thanks for watching Astrotech. If you found this video helpful, don't forget to like, share, and subscribe for more amazing tech content. See you in the next video. Stay curious, stay innovative.